This video is on topics 6a and b, the powers of I, and the operations on complex numbers. So the powers of I follow this little pattern. We know that I is the square root of negative 1, so I squared is to square the square root of negative 1, which will just be negative 1. And I cubed is really like I squared times I, which would be negative 1 times I, so negative I. And I to the fourth would be like I squared times I squared, which would be negative 1 times negative 1, which is positive 1. And then it starts this whole pattern back over. So I to the fifth is like I to the fourth times I, which is just going to be I. And then I squared, or I to the sixth is just like I squared, because it's the fourth times I squared. So that's going to be a negative 1. And I to the seventh is just like I cubed, which is going to be negative I. And I to the eighth is just like I to the fourth, which starts back over at positive 1. So it's sort of this like module, every fourth restarts this pattern. So we do problems by taking the exponent and dividing it by 4 and seeing the remainder, because that's where it starts over, is after the fourth. So to do problem 1, I take 13, my exponent, and divide it by 4. And all I care about is the remainder. So that's going to be 3 remainder 1, but really it's the remainder that I care about, because that means that this is going to behave like I to the first power, which is just I. Problem 2, I do the same thing, 46 divided by 4. So you take the exponent, divide it by 4, that's going to give me 11 remainder 2, but all we care about is the remainder. The remainder is your true exponent here, which is I squared. And I squared is negative 1. Problem 3, we take our exponent, divide it by 4, and that's going to be 5 remainder 3. So the remainder of 3 means that this is really like I cubed, which is negative I. Try number 4 real quick. So when we divide by 4, we get a remainder of 0, which means it's like I to the 0. And if you remember, anything to the 0th power is really just 1. So if your exponent is divisible by 4 evenly, then your answer is just 1 every single time. So a complex number is when we have a real and an imaginary sort of combined. It's not just imaginary, it's actually both. So it's always written with the real number first and then the imaginary second. We sort of treat i's like we would a variable. That's how we do these problems. So for topic 6b, when we're adding, subtracting, multiplying, even dividing complex numbers, we're just going to treat it like I is sort of a variable where we know what it stands for. It's not varying, it's just a replacement. So for problem number 5, we're going to treat it just like we would with polynomials, where we would distribute that negative inside. So we'll get a negative 8 minus 9i minus 7 minus 2i. And then I combine my like terms. So my negative 8 and negative 7 make a negative 15. My negative 9i minus 2i is minus 11i. We always write it where the real number is first. So that nice normal negative number comes first. That's our answer. Pause the video for a minute or two and try number 6, then restart it and see if you match my answer. So the first groups here are just being added, so the parentheses aren't doing a whole lot, but that negative is going to affect the 12i. Then we combine our like terms, and this is going to be our final answer, 9 minus 8i. We just did adding and subtracting. When we talk about multiplying complex numbers, it's going to be just like multiplying polynomials with just a little bit of a twist, and that's because I squared is not just like x squared, but it's negative 1. We just found that out earlier. So when we go to do these, it's going to add a little bit of a twist to it. So problem number 7, I would distribute just like I would in any other normal problem, and we get 15 minus 30i. There's no I squareds, so that's just it. Normal complex number. Number 8, though, is a little bit different. We have to FOIL it, so we're going to do negative 12 plus 8i, and then a plus 27i, and a minus 18i squared. So now, middle terms will combine, just like normal problems, normal polynomials with x's and y's and stuff, but this I squared is going to be a little bit funky. So the negative 12 is normal plus 35i from the middle, but this negative 18i squared is really negative 18 times negative 1 because I squared is negative 1. So now we can actually combine it further, and we'll get negative 12 plus 35i plus 18, where we have some more like terms. So that's going to give us a 6 plus 35i. Number 9, we do the same kind of idea. So I want you to actually pause and try your best to do this problem number 9. So I got 11 plus 5i for my final answer with number 9. Number 10 adds just a little bit of a twist in that we're actually squaring one binomial. So the only difference is that we have to sort of set it up with this extra step to say that 5 plus I squared is really 5 plus I times 5 plus I. And then we do the same process that we just did. So give this one a shot. My final answer, I got 24 plus 10i on this one.